Good evening and welcome back to NASA's Johnson Space Center and our post-landing news conference for the Starliner crew flight test. Starliner touched back down on Earth today or yesterday, depending on where you're watching from, at 11:01 p.m. Central Time or 1 minute after midnight Eastern Time. Here today to discuss the mission with you and wrap it up, we've got Joel Montalbano, the Deputy Associate Administrator for Space Operations Mission Directorate at NASA headquarters in Washington. Steve Stitch, the Manager for the Commercial Crew Program from NASA Kennedy Space Center in Florida, and Dana Weigel, Manager for the International Space Station Program here at NASA Johnson. I'll let them each make some opening remarks, and then we'll open up the floor for a question. If you do have a question, you can on the phone bridge, you can press *1 to let us know. Let's start with Joel.
Well, first of all, thank you for joining us, for those here in the room and for those online. As was said, NASA and Boeing safely returned the Starliner spacecraft just after 11 p.m. Central Time to the White Sands Space Harbor in New Mexico after spending approximately 3 months attached to the International Space Station. It's great to have the Starliner home. A safe and successful landing was exactly what we wanted. It was uncrewed. Everybody see the systems work is exactly what we wanted. It's important to remember this was a test mission, right? This mission. The team spent a lot of time understanding the board, doing additional testing out at White Sands, doing analysis here. And I mean the team, the NASA team, the Boeing team, you know, across the partnership. We worked together to get this data and pull things. You know, we did learn a lot. This was of a crew, you know, the Starliner on the Atlas V, and the procedures and the processes for that. On approach, some manual piloting. We had a successful docking, and we had 3 vehicle on board the International Space Station as we learned to operate with the systems and the crew and the interfaces there. I want to go ahead and thank the Boeing team, the Commercial Crew Program, International Space Station Program, our international partners, and all the engineers that worked on this mission to get us where we are today. With that, I'll hand it over to Steve. Thank you.
Yeah, thanks, Joel, and thanks for your interest in the Commercial Crew Program, and thanks for being here at a relatively late hour. It was a great day today to return Starliner. It was great to have a successful undock, the orbit and landing of the vehicle. We're really excited to have Calypso back on the ground. You know, Sonny told the ground team, "You've got this, bring Calypso back," and that's what they did tonight. I am thrilled for our Boeing team and all of our colleagues that worked this mission across the country, on the NASA team and the Boeing team. They've put a lot of heart and soul into this mission over many years, and it's a testament to those people that we got the vehicle back safely today. I can tell you that CFT is very personal to our team and to a lot of the people that worked on the mission, and it represents a tremendous honor to bring the vehicle back, to achieve a lot of test objectives today when we brought the vehicle back, and then really pave the way for future Starliner missions. I'm happy to report Starliner did really well today in the undock, the orbit, and landing sequence. You know, we used the NASA docking system for the second time on the mission to undock from the space station. That system performed really well. It's a derivative system what we use for Orion down the road, so it was good to pave the way for Orion as well. The spacecraft executed a nominal breakout sequence, the first time we've used that. To back away from the station, we backed out to about 5 meters and then did a series of about 12 burns using the service module forward jets. And then we opened, after that sequence of maneuvers, we ended up opening at about 22 kilometers per rev away from the space station. All those thrusters did really well through that SEP sequence, no problems at all, no fail-offs or any problems at all. You know, we had a good chance to look at the helium system today when we before we undocked, we repressurized that system. We had a criteria of 8 psi per hour in the ullage system for that, the helium, and we were about 4.5 psi per hour, so the helium system performed really well. And then, you know, when we backed away from the system, or from the space station, we did hot fire a number of thrusters on the service module. All 8 of those forward thrusters worked just great. We were able to look at the thrust of those thrusters, and it was nominal. All were performed at 100%, and we also hot fired 2 aft thrusters, and those worked well. We had great performance from the GNC system, the Guidance Navigation Control, the Vesta system. Last flight on OFT2, we had a little bit of trouble with what we call a calibration maneuver to really make sure that the attitude is good for this Space Integrated GPS INS system, and that went really well. We had a deorbit burn that executed on time at 11:17 p.m. Central. It was about 130 meters per second, 58-second burn. It was a really good burn, and the service module thrusters performed well for that burn. The OMACs performed well. We watched the burn. We saw a couple things in the starboard doghouse. We talked a little bit about the temperatures there being a little higher. One of the thrusters, S2A2, didn't fail off, but it had a little higher temperature than expected, so we'll look at that data a little bit after the flight. And then another thruster in the top doghouse had a little higher temperature. We intentionally had planned to inhibit the software to let thrusters fail off during the deorbit burn, and that worked fine. So we really need to go back and look at all that data. The service module separated away just fine. That sequence went well. Once we separate the service module, we don't have good insight into those thrusters on the service module, but we expected it to be in the Pacific Ocean right where we intended it to be. During entry, the vehicle performed great. It flew just fine. The GNC system performed well. Perfect entry. The one thing that we will have to go look at after the flight is when we hot fired before we had the entry, we hot fired on the crew module. There's 12 thrusters, and one of the upfiring thrusters did not perform at all. We hot fired it twice, and we used two different methods to talk to it, two different parts of the avionics system, and we never saw any chamber pressure or any pulses there. It looked like this is different than the service module thrusters. It's what we call a monopropellant system. It's very simple. It has a valve that opens, and then the propellant flows across the cat bed. And as it flows across that cat bed, there's a reaction and causes thrust. And for some reason, that thruster did not perform. But we used the redundant thruster on the other manifold. There's another upfiring thruster that worked just fine during entry, but something we'll have to go work at. It was a bullseye landing, great landing out at White Sands. The one thing we worked a little bit during entry is, for some reason, when we came out of the plasma, the navigation system, we call it the SIGI-3, kind of failed off temporarily, and then that system was brought back on, and it was tracking just fine. SIGI-2 also had a couple little hiccups during entry. We'll have to go look at that. That's really the only things that happened during entry. The sublimator that we had a little trouble with, that's a cooling device that is used to cool the vehicle during entry. It performed really well. We had a little trouble forming what we call an ice block on that during ascent, and that performed great tonight. It's really great to get the spacecraft back, and then we'll start the next steps. So we've been talking to the Boeing team already about next steps. We want to get into the spacecraft and start working on the helium system. We talked about, we know we have a seal that we've got to go replace on the flanges on the RCS thrusters. We need to upgrade that material to make it hypergol compatible, and then maybe a little bigger size. We'll do that. Boeing's already formed teams to look at the changes that need to be made for Starliner 1 in terms of the thermal environment in the doghouses. Can we do something different to make the doghouses a little less thermally severe for the OMAC burns and the thrusters? A second team is looking at the hot fire of the thrusters that's needed on the service module to complete the qualification and make sure we understand which pulses cause the Teflon seat on the oxide to swell. And then thirdly, there's a GNC team already formed to look and figure out how we go fly the vehicle differently. Can we change the dead bands? Can we change the way it flies to not stress the thrusters? And so that work has already started. And that's really the path to Starliner 1. So I'm super proud of the team. It was a great day for the Commercial Crew Program and also for Boeing. Congratulations to that team who worked so hard. It's great to have the spacecraft back, and we're now focused on Starliner 1, and I'll turn it over to Dana.
Thank you very much, Steve. And thank you all for being here with us at this very late hour and for your interest in the undocking of the Starliner from the International Space Station and its successful landing. I want to congratulate the Boeing team. They did a fantastic job with the operations this evening. They had to make a number of changes to the plan in short order. There were a lot of differences between the crewed and the uncrewed mission, including, as Steve talked about, the differences in the departure sequence fantastic job executing that. After Starliner undocked from the Harmony or Node 2 forward port, it backed away and then executed a series of breakout burns. It went up, over, and behind ISS. The crew was watching it until it was out of view, but then they came back and they watched the re-entry and the deorbit. In fact, they got some really neat views of the Starliner streaking through the atmosphere using some of the station video cameras on board. Pretty neat to see. The rest of the month in front of us on board station is really busy. I know I've talked to you about this before, but just as a reminder, next week we've got the Soyuz crew exchange with the launch of the 73 Soyuz on September 11th, bringing up NASA astronaut Don Pettit. And then we're returning NASA astronaut Tracy Dyson on the 72S Soyuz when that comes home. At the end of the month, we'll bring up Crew 9, do a handover between Crew 8, Crew 9, and then bring the Crew 8 vehicle home. I do want to express my sincerest appreciation for the team. They worked tirelessly over the whole summer. You know, we had the Starliner on board station for months. Most folks were working nights, weekends. They did an excellent job. The proof is in getting the vehicle safely home today. I know we've got a lot of things that we learned on the mission. We've got work in front of us, but I know that we've got the right teams in place to tackle these challenges and help us fly our future Starliner missions. And with that, I will hand it back over to Brandy.
All right, thank you. Okay, so we're going to start with questions here in the room, then we'll take them from the phone bridge. Reminder, if you're joining us by phone, let us know you have a question by pressing *1. And if your question gets answered and you want to withdraw it, you can press *2 to get out of the queue. But let's start here in the room. How about Eric?
Hi, Eric Berg with Ars Technica. Thanks for the great show tonight. That was really a stunning reentry. I wanted to ask about the arc of the commercial crew program. I was going to ask both Boeing and NASA, but I guess they didn't show up for some reason. But anyway, it's been a decade since the CCT CAP awards were given out. I had to go look up that acronym. I'd forgotten it. It was a big experiment in fixed price contracts and human spaceflight. And so I'm just wondering, a decade later, and literally it's been a decade, after all that's happened with Dragon, with Boeing, with the delays, and now with this mission, just to get a sense of you from NASA, is the experiment a success, and kind of what is the future of human spaceflight with this commercial approach?
I'll start, from a commercial standpoint. We have 2 crew vehicles, the Dragon, Starliner, and obviously some work that we need to do on Starliner. We have commercial vehicles with cargo vehicles in the Dragon and the Northrop Grumman Cygnus. We have the Dream Chaser that's coming up next year. And so is it slower than what we expected? Absolutely, right? It is slower, but we're making progress. And to me, we are learning. Every time we have a mission, we learn something. That gets passed on. We're sharing things across the commercial world. You saw, last year, I'll say, Blue Origin had that parachute anomaly, and the teams all got together and shared across the different companies, what they learned. And to me, that's what this program is helping out. It's sharing the expertise of flying in space. And I'll let Steve and Dana add.
Yeah, I think that's an interesting retrospective way to look at things, Eric. The fact that here we are 10 years into the program, and how are we doing? I would say we've done a great job at fielding 2 transportation systems in fairly record time. If you look at our development programs these days within NASA, commercial crew has done an amazing feat of getting to 2 crewed vehicles in 10 years, and really in the last 4 years, bringing along online Dragon, Crew Dragon, and then also now Starliner. The unique thing that we're doing as well is sort of fostering this market in low Earth orbit. We already see SpaceX flying non-NASA flights. They have one that they're trying to get off the ground, Polaris Dawn. They flew Inspiration 4. They've flown a number of PAM missions. They've got another PAM mission coming up in the middle of next year. So you're starting to see that market get fostered in non-NASA missions, which was what we want. And then if you really think about our vehicles and what we really want to do, Space Station's a great vehicle. It's an awesome place. But at some point, the space station is going to need to be retired. And so we're preparing vehicles right now to be there in the future for these commercial LEO destinations as well. So I think it's been an interesting, as you said, and when we started, it was kind of an experiment on the heels of cargo. But now we're starting to see, the benefits of the investments by both NASA and our partners. And that's the one thing that's different about our program is there's investment from both the NASA side and also, in my case, SpaceX and Boeing to make the vehicles safe and successful.
All right. Mark?
Oh, thank you. Mark Carreau with Aviation Week in Space Technology. How long would you sort of estimate that it will take the commercial crew program, space station partnering or whatever to sort of assess this flight and what steps need to follow, just kind of to make a full report that you're all satisfied with that lay out steps ahead?
Yeah, I think the timeline is a little bit, we're going to take our time to figure out what we need to do to go fly Starliner 1 right. We've laid out right now, manifest-wise, we have that flight booked next year in the second slot of the year. The first thing we'll do when we get the vehicle back is continue to look at all the data, look at the thruster performance for this phase of flight in detail. And then we already have these teams that I've talked about established. They're going to start meeting weekly on looking at the design changes required in the helium system to eliminate the leaks. And then can we fly the vehicle different? Can we change the thermal in the doghouses? What testing do we need at White Sands? It'll take a little time to lay that out and then get into the testing. And then, I think we'll see where we're at in another month or so, and then we'll have a little bit better idea of what the overall schedule will be.
Okay. Gina, go ahead.
Gina Sinceri, ABC News. I'm not sure who wants this, but we heard a lot about the problems, but what about Starliner's performance particularly impressed you or surprised you in a positive fashion?
Yeah, I would say not a surprise, but if I just look at the 3 flights we've flown, OFT-1, OFT-2, and CFT, the Starliner performance and executing the entry phase has been just about flawless, other than the problem we see with the SIGI when it comes out of the plasma a little bit. It has a little trouble acquiring in one of the receivers, it seems. But if I look at the way the vehicle flies, the thruster performance, hitting the target at the landing site, the parachute deploys, separating the forward heat shield, and getting the drogue parachutes out, stabilizing the vehicle, then putting the main parachutes out, and then separating the heat shield, which is a complicated separation, and deploying the airbags. The third time now we've landed a capsule in the U.S. on land. The entry in particular has been darn near flawless. So that, I wouldn't say it surprised me, but as I step back and think about the mission, the entry itself was just, and the orbit burn was spot on.
Okay, why don't we go to the phone bridge next? We will start with Marcia Dunn with the Associated Press.
Yes, hi. Probably for you, Steve. It sounds like you won't require another test flight, that an operational Starliner 1 with the crew will be next. Is that how it looks as of today? Am I understanding that correctly, that the next flight will be fully certified, ready to go with the crew to be a real crew swap? Thanks.
Yeah, I would say it's probably too early to think about exactly what the next flight looks like. I think we want to take the steps to go look at all the data. Certainly our goal is to get to the rotation flight. Our goal all along has been to have, one flight a year, one flight from Boeing Starliner and another flight from SpaceX with Dragon. So it'll take a little time to determine the path forward. But today we saw the vehicle perform really well. We've got some things we know we've got to go work on, and we'll go do that and fix those things and then go fly when we're ready. So.
Thank you, Marcia. How about Bill Harwood with CBS News?
Yeah, thanks. And actually, Marcia just asked my question, so let me ask you a different one for Steve Stitch. If a crew had been on board the spacecraft tonight, would anything have been different or would it just have been the same reentry we saw? Basically, I mean, I know you had a quick fly out to get away from the station without the crew on board, but just from a crew standpoint, if they had been on board, just for the record, everything would have been fine. Is that correct?
Yeah, if we'd have had a crew on board the spacecraft, we would have flown the same back away sequence from the space station and the same deorbit burn and executed the same entry. And so it would have been a safe, successful landing with the crew on board had we have had Butch and Sonny on board.
I know that you don't have second thoughts about these things, but would you have any second thoughts about the decision not to bring them back if you had it to do over again, knowing what you know now about the landing?
Yeah, I think it's always hard to have that retrospective look. You know, we made the decision to have an uncrewed flight based on what we knew at the time and based on our knowledge of the thrusters and based on the modeling that we had. And we, you know, if we'd have had a model that would have predicted what we saw tonight perfectly, yeah, it looks like an easy decision to go say we could have had a crewed flight, but we didn't have that. We didn't have a way to take that white sands testing and anchor it in a model. And so I think we made the right decision to not have Butch and Sonny on board. It's awfully hard for the team. It's hard for me when we sit here and have a successful landing to be in that position. But you know, it was a test flight, and we didn't have confidence with the certainty of the thruster performance, and that's really what led us to choose to have the uncrewed test flight.
Thanks.
Okay, next we'll go to Sawyer Rosenstein with NASASpaceflight.com.
Thank you for taking my question. First off, congratulations on that successful landing there. You earlier mentioned about that nav system dropout as it was coming out through the plasma there. Can you kind of explain what role that has, and did that come back online on its own? Was there some ground intervention needed? Just what exactly was done to resolve it?
Yeah, the way the nav system works is we have 3 devices that essentially are like a GPS and then also measure velocity and the orientation of the spacecraft. And so when we came out of the plasma, one of the third SIGI, Space Integrated GPS INS, had trouble acquiring. And so the software said it wasn't performing well. It didn't have enough satellites, and it failed it out. The ground team looked at the 2 remaining systems, SIGI number 1 and SIGI number 2. SIGI number 2 wasn't receiving marks as well as it should have. They analyzed SIGI number 3, did a great job looking at that, and then brought that back into the nav set. And so we had 3 essentially GPSs, and then protected for if number 2 would have been completely bad. So the team did a great job. I think we just need to look at, you know, do we need to allow a little bit more time for the GPS to acquire on the backside of the blackout. And the flight control team, again, did a great job recovering that GPS.
Thank you. Let's go now to Will Robinson-Smith with Spaceflight Now.
Yes, hi. Thanks for taking the time to speak with us after a good landing. Follow up on Mark Harrow's question about timeline, but in a slightly different way. When do you expect that Calypso will arrive back at the Kennedy Space Center, and what's the immediate work that will need to be done once it arrives here? Thanks.
Yeah, don't have the exact timeline. It usually takes a couple of weeks to get it back. One of the first things that happens when it comes back is a lot of the data that we get on board the spacecraft goes through the tracking data relay satellite to the ground, and we can see that telemetry in real time. But there's also recorded data on board. For the test flight, we have a number of sensors across the systems that record data. We'll want to downlink all that high-rate data and take a look at that data. And then really it's a series of analyzing all the data from the entry, the undocking, and the deorbit across all the systems on the vehicle to just see if there's anything that was off nominal. We'll study the data at a little higher rate. So, you know, it'll take a couple weeks to get it back and a week or so to get the data off the spacecraft.
Okay. Thank you. Robert Perlman with Collect Space.
Thank you. when Apollo 13 safely landed, NASA described the mission as a successful failure. Is that how you would label the outcome of this flight, given that Starliner's landing was safe and successful, but it failed to bring the crew home?
Joel, I would not call it a successful failure. We knew going in this was going to be a test mission. We learned a lot. The teams worked together, both the Boeing and the NASA team, to understand the systems of the spacecraft and how they operated. The team worked together at White Sands to understand the analysis that was done. You know, on the test mission, things don't always go as you planned. And so we were prepared. The fact that this vehicle is home, we're very happy to have the vehicle home. To me, a success. You know, clearly we got some work to do. The teams will understand that work and move forward.
And if you just look at mission objectives, you know, we think we've probably got 85 to 90% of the mission objectives. We docked with the space station. We stayed docked for 3 months, as Joel said. There's a lot of learning that happens in that 3 months that is invaluable for an increment mission. We did a half of an increment, essentially, having the vehicle there, understanding how to work. The Starliner team worked with the ISS team, analyzing the data for those 3 months. So in some ways, the mission overachieved some objectives in terms of being there for extra time. Not having the crew on board, obviously, there's some things that we lack in terms of Butch and Sunny's test pilot expertise at how the vehicle performed, what they saw in the cockpit. We won't have that data, but we still have the wealth of data from the spacecraft itself. And so that will go toward the mission objectives and the certification of the vehicle.
Thank you. Stephen Clark from Ars Technica.
Hi, good morning. Thanks for taking my question. A couple ones, if I could. Steve Stitch, you mentioned a couple of the thrusters on the starboard and top doghouse got a little warm during the deorbit burn sequence, I believe. You said you inhibited some of the limits to prevent them from failing off during that deorbit burn. If those normal limits have been in place, would those thrusters have been deselected at the temperatures they reached? And also, since no one from Boeing is there, Steve, I'll ask you this. What's the kind of the state of the service module for Starliner 1? Is it fully assembled? Do you have to start taking it apart to get to these seals that you may need to replace, and any other hardware changes you might need to make before that mission? Thanks.
Yeah, let's see. Relative to the temperatures getting a little high, I don't have the data with me to see whether it would have failed off or not had the software been enabled. We intentionally had planned to fly the flight with the software inhibited even before the thruster problems. We had seen some overheating of some other parts of the thrusters in previous flights, and so we wanted to go ahead and have that flight detection or fault detection system inhibited for the deorbit burn. So I'm not quite sure can answer the question whether they would have failed off. And then relative to the service module for Starliner 1, it's in the middle of being built. We'll get to a point where we have assembled the doghouses at some level, and then we'll have to stop and wait to see what the design changes are. Do we remove some of the thermal blankets inside those doghouses? Do we make some changes to make it a little cooler when we fire the OMAX and also the RCS thrusters? So it is in a state of build and undergoing the final build process, but we'll hold for the final doghouse assembly until we understand the design changes.
Thank you. Apologies if I mispronounced this, but Isam Ahmed from AFP.
Yes, hi, thanks. Yeah, just to follow up on a couple of questions from before. Is there an actual chance that the next flight could indeed be crewed without requiring another uncrewed test? And is Boeing pushing for that, or have they spoken to you about that at all? And just wondering why they're not on the call. Thank you.
Let's see. We'll start from the end there. We did talk to Boeing before this. They deferred to NASA to represent the mission. I will tell you that Boeing has critical work that they do for NASA in the International Space Station program, the Commercial Crew program, and the Space Launch Systems program. And their work is critical to our success, and we fully expect Boeing to continue all three of those programs.
And I think, relative to getting to our final capability of having a certified vehicle and having a capability to do the rotation missions with space station, I think both Boeing and NASA share that goal. We would both like to get there. I think we just need a little time to lay out the plan and look at what testing is required and look at how can we validate that testing in flight, and then what would be the risk with proceeding once we understand the design changes. So we just need a little time to work through that.
Okay. Let's go next to Jackie Goddard with Times of London.
Hello, thank you. Yeah, just following up on that last question, we're not getting straight answer to why aren't Boeing here. I know you all want to be diplomatic, but can you kind of give us an open, honest assessment of, is there a kind of healing process that now lies ahead? This kind of should be a sort of moment of celebration, but we don't have the Boeing folks here at the table. There's no explanation why. It doesn't appear that there's joyful unity, if there is. How do you folks fix the rift? Is there a rift? Is there damage being done to the relationship? Thank you.
Okay, so I'll answer again. We talked to Boeing. They said, hey, we'd like NASA to take the press brief. They deferred to us to talk the mission. I can tell you that the three of us have all talked to the Boeing managers after the landing. The Boeing managers came into the control room and congratulated the team, talked to the NASA team. And so Boeing is committed to continue their work with us.
And I think, from a human perspective, all of us feel happy about the successful landing, but then there's a piece of us, all of us, that we wish it would have been the way we had planned it. We had planned to have the mission land with Butch and Sunny on board. I think there's, depending on who you are on the team, different emotions associated with that. And, I think it's going to take a little time to work through that. For me, a little bit, and then for everybody else on the Boeing and NASA team. So.
Okay, next up we have Micah Maidenberg from Wall Street Journal.
Hey, everyone. I think this would be for Steve. Steve, closing the mission, I think, unlocks a milestone payment for Boeing. Is that right? And how much would that payment be? And would Boeing get all of any payment, because Starliner came back uncrewed and I think, as you mentioned a couple of minutes ago, got to 85 or 90% of the objectives for the flight? Thanks.
Yeah, so there are a couple milestones out there relative to ops readiness that we'll have to assess, and then certification is the big one. That's the big one that's coming up. And we're working toward that. We'll have to look at, relative to the systems that need to be changed, what does that mean for certification? There were some changes to the vehicle that we talked about pre-flight, that there's some changes to the suits that are going to happen, changes to the seats that affect certification. And then obviously another aspect that has to happen for certification is we need the vehicle to go to both Node 2 forward and Zenith port. And those are all wrapped up in certification. So we're in the process right now of laying all that work out in terms of what we had planned to do, and then obviously what the changes are. And then we'll assess that milestone when it's the right time.
Okay, next we'll hear from Marcia Smith with Space Policy Online. Marcia, if you're online, you can ask your question now.
Sorry, I thought that Michael was still asking a question. But anyway, my question had to do with the crew module thruster. And I'm curious, when was the last time that thruster was tested? And were there any problems with the crew module thrusters on the previous two flights?
Let's see, that's a good question. That thruster, the upfiring thruster, CTU-2, was last used in 2019 on the OFT-1 mission. It performed well. All the thrusters on OFT-1 on the crew module performed well. We did have one thruster that was deselected by the software on OFT-2. This was the crew module thruster. It was very late around the time frame of drogue deploy, and we figured that out to be a command problem. So where the command didn't come out of what's called the integration propulsion controller correctly to the thruster, we took that thruster off the vehicle, and we sent it back to the vendor. The vendor tested it, hot fired it. That thruster worked fine. This thruster today looked different, I would say. In terms of multiple attempts to hot fire it, it had no response at all. The thruster that had failed off due to a command problem had multiple thruster firings. It passed the hot fire in OFT1, in OFT2, and then also had multiple firings during the entry. This one, for some reason, just never fired, and so it looked like the valve perhaps was not opening for some reason. So we'll have to take that thruster off the vehicle when we get it back to the C3PF, send it back to the vendor for some analysis, and then we'll know more about what the fixes are for that as well.
Okay, now we are going to go to David Curley with Full Throttle.
You've talked to Steve in the past about, what do we do about the vehicle? Is it changing some of the materials in the thrusters? Is it redesigning the doghouse? I know you have a lot to learn still, and so does Boeing, but how much work do you think is actually ahead? Is it just using a computer to tell the thrusters to fire in a certain way, as you did on reentry today, to change their performance? What do you actually think you'll have to do?
Yeah, that's a good question, and we have again several teams off looking at that. What we would like to do is try not to change the thruster. I think that is the best path. The thrusters have shown resilience and have shown that they perform well as long as we keep their temperatures down and don't fire them in a manner that causes the temperatures to go up, that then causes either the vaporization of the oxidizer, which causes low thrust, or the poppet swells. Today, obviously, the thrusters had all recovered at station, and obviously it looked like today we didn't have those high temperatures. We knew that the downhill phase would be a little less demanding on the thruster than the uphill phase. What we need to do now is go take a thruster at White Sands and make sure we understand the exact pulse sequences that caused the heating, and then at the same time, in parallel, look at software changes to reduce the number of demands on the thrusters, and then in parallel with that, look at the doghouses and see if we can, again, they're trapping a bunch of heat. We know that when we fire the thrusters, the doghouses are trapping heat. Can we go make some changes to the blankets and the inside of the doghouses to keep the thrusters cooler? So it's really 3 different thrusts, I would say.
Okay, next up we have Jonathan Woods with Working Tens.
Hey, thanks for your time this morning. Reflecting back on the question that was asked about the successful failure with Apollo 13, if we think back about 2020 when Crew Dragon Demo 2 launched, I think the most significant issue that we faced during that mission was launch scrub due to thunderstorms during it was Tropical Storm Bertha. Thinking about that, when we say this mission is a success, how do we position this versus the relative success of a 60-odd day mission with Demo 2 compared to the insurmountable challenges, the testing, and everything that had to transpire to make the difficult decision to keep crew on board stationed for a very long duration mission?
Yeah, I'll take it and see if Joel has anything to add. When I look back at Demo 2, Demo 2 was very clean in flight. However, I think a lot of people forget that after landing, we discovered there's a device called a tension tie that goes in between the Dragon spacecraft and the trunk that attaches the two together. And there's a very complicated thermal protection system closeout around those tension ties. We found out after the flight that we had some erosion around that thermal protection system area, and we had to go change the design in between Demo 2 and Crew 1. We made some substantial changes. to that closeout and then went and flew. So Demo 2 had its challenges as well. I think every test flight has its challenges. What we see with Starliner is a very robust spacecraft, but yet we have some challenges with the thrusters that we've got to go attack and move forward and fix. I wouldn't call them insurmountable. I think, what we've seen out of the Boeing and NASA team is a resilience and able to overcome challenges, and we just need a little time to go work through it. I think we learned a ton during this flight, which is invaluable moving forward to Starliner 1. Now we just need to take that learning and make some changes to the system so that we don't overheat the thrusters, and I'll see if Joel has anything to add.
And the only thing I'll add is, the lessons learned that we have on these demo missions play forward to other future missions. The question was asked earlier, do you think the programs, the commercial programs have been a success? And yes, these lessons learned that we're able to take from both the Boeing mission and from the Dragon missions are lessons that we are carrying forward for future missions and future providers such that we can continue to develop the low Earth orbit commercial.
I would just add that it's really hard to compare the Demo 2 mission to this mission. Keep in mind that we took a different path with the Dragon vehicles. We developed cargo capability first. So by and large, things like dealing with prop systems and a lot of the things that we're now learning with the screwed flight test were dealt with during the cargo era. And then we upgraded the vehicle for crew. So very different development paths between the two spacecraft.
That's a really good point.
Thank you. Okay, next we're going to hear from Mike Wall with, I'm sorry, it disappeared, but Mike Wall.
Yeah, hi. I'm with Space.com, actually. Thank you for taking my question. I just wanted to say, first of all, congratulations on a successful landing. And second, I was just wondering if you heard anything more from Butch and Sunny, just kind of how they're feeling today, what their reactions were to the landing, and just how they're feeling about, the next few months that they'll be spending on orbit. Thanks.
I haven't spoken to them today. Obviously, today was really busy. They were on board doing a lot of work for us. They did wish the vehicle well and best wishes for the landing. And of course, they watched it the whole evening. So no updates from what I reported before. After station's always busy. I know I always tell you guys that, but after Starliner departed, they were off working on other activities for us. So right away, they jumped into some other work. So no other updates from what I've reported to you previously.
Okay, and we've got one more question on the phone bridge from Sophie Sanchez with Cosmic Chicago.
Hi, thank you for taking my call. I had a question about the failed thrusters that were mentioned. Was the redundant thruster that you mentioned part of the same system? And just a hypothetical question, I guess, if that had failed, what would have been next, and what could have happened if they both failed? Thank you.
Yeah, we did have a redundant thruster available on the crew module to do the function that we needed. We did need that thruster to work during all of entry, so I wouldn't say all of entry, but through the highest part of entry to a certain phase. If that thruster would have failed, it would have been acceptable. But once we got off the separated from the service module, we no longer have those thrusters. So the one remaining up-firing thruster worked just fine. We'll go back and understand what happened with the CTU-2 thruster that failed, and we'll go solve that problem and move forward.
Okay, we did have one more question come in from Kenneth Chang with the New York Times.
Yeah, hi, thank you. This is for Steve Stitch. So during this news conference, you've outlined a bunch of work that you need to do, especially with the thrusters and the doghouses. In the past, you've also mentioned that it's really hard to test the doghouses on the ground because getting the whole system to mimic what you see in space. How will you be able to get enough data through simulations and through testing that you have the confidence for Starliner 1 without flying another test flight?
Yeah, that's a great question. We're going to take the data from this flight and work to build models on the ground, and then we're also going to look at, is there a way to test what I would call an integrated doghouse on the ground in a vacuum chamber. We've got some ideas on maybe how to do that. At White Sands, we'll put a team together to see if we can actually put it in a chamber and fire the OMAX and the other thrusters and get that data in that environment, and then extrapolate that data to the orbit vehicle. So there may be a way. We just need a little bit of time to work through that.
All right. Well, I think that is our last question, so we will wrap up there. Thank you so much to our briefers for sticking with us through a late night. We really appreciate it. And thanks to all of you for following along with Starliner's test flight. We appreciate that as well. Please continue to stay tuned. Next week, Wednesday morning at 10:15 a.m. Central, 11:15 a.m. Eastern Time, we're going to be having the coverage of the Soyuz MS-26 launch, carrying NASA astronaut Don Pettit and his cosmonaut crewmates Alexei Ovchinin and Ivan Wagner to the International Space Station. So more to come in space. Please stick with us, and we appreciate your coverage. Thanks so much.